Yeah, we can
can
see.
see it.
Okay, okay. So we can start. So today we will have our Dobot CR series basic training, and when we finish this, we will also have the advanced training. Normally in the past, we will separate. It's 2 days course, but because it's online, so maybe the practice will not be so much. But we will I will try my best to try to show you some or guide you some demos. I've also seen that you have the one CR3S in your face. So later maybe you can also follow steps to try some functions of that. Uh, Need to note that in the basic and advanced training, there's no um, depends about the safe skin and the grippers. But if you have questions about the grippers or the safe skins, we can also discuss in the FAQ session later, QA session later. Yeah. So during my presentation, if there's any questions, you can break me anytime, and I will answer you. So let's start um, from the basic training first. So the course introduction, the first part, like through this basic training, you need to understand. A purpose is that you can understand the basic function of the robot device, including the control box, the robot arm, and some accessories like the Wi-Fi module or other like grippers and how to assemble it. The second one is to understand the feature, like how to use the control software. We have the control software like on the tablet, we call the CR Studio. On the Windows system, we call it Dobot Studio Pro. So maybe you only have the Windows. So I will show you how to guide you how to use the control software, Dobot Studio Pro. And the third one is we need to be able to configure it and adjust the coordinate system, and also the tool system. I will introduce both of them later. And the third one is to understand how to use the graphical. We also call it broccoli programming. That's very easy, and we can try to use it later. And also the logic, and also I/O signal configuration. The last one is based on our training platform because you don't have the training platform. Maybe we cannot do all the practice, but we will do part of them. This is the training platform in our training loan. But I can show something, just show the video to you. It's also a CR3, and there's a conveyor to cooperate with the robot to do some palletizing and some simple pick place work. And also there's encoder, yeah, and the air pump. Okay, because you don't have the training platform, so maybe we will skip this part. So mainly we have 5 parts for the basic training, including the hardware, software, coordinate system, broccoli programming, and also system I/O introduction. So when you get the CR series, you will receive this including the CR5 robot arm in one box and also a controller in another box. So in the robot box, including the quick start manual and the calibration whole base paper, guide you how to install the robot on your platform, and also the wireless connector used to connect to the robot via Wi-Fi, and also a tablet, but tablet is an option, so you need to place the order in advance. So if you didn't place order for tablet, maybe there's no tablet. And also the heavy duty cable, which is used to connect between the robot and the controller, and also the power cable. Of course, there will be emergency button for each robot, and also I/O tool I/O extension cable used to connect to the grippers, and also the robot arm. And here I take CR5 as an example. The other box there will be the controller. For CR series, the control box name is CC161. And here's a short video about the about the unboxing. So you will have two boxes. There's a series number of the box and also the robot. All the cables, the wireless connector. How to install the robot.
بس الخشب
讲课。
So the machine comes with certain specifications. Okay, we need to do that. Yeah, we need to certain specification for the machine.
Yeah. It's immediate or
Then video.
okay.
Okay, so the first some maybe 3 or 5 minutes is about the unboxing, And the following will be the download of the software. I will also introduce it later, so let's just skip this part. Okay. So as introduced in the video, here is the control box. We call it CC161. That's the model. And there are the introduction about the port. The first one is the USB interface for connecting Wi-Fi module. The second one is teach pendant or emergency stop switch interface. So you can connect a teach pendant if you ordered a teach pendant. If not, you need to connect with emergency stop button. Number 3 is the LAN cable connection for the from the robot and your laptop. So the default IP address is 192.168.5.1. So for the PC connection, you need to set your PC IP address to the same segment. For example, 5 here. This address can be modified. So the connection for the LAN port also support like TCP/IP or Modbus protocol. Number 4, here is the universal I/O interface. Number 5 is the input power switch, is to power on or power off. Number 6 here is AC 220 volt power connector. Number 7 is DC 48. This one is reserved. Is customizable. It's like when you order the controller, you need to tell us you want the AC one or the DC one, but you can only choose one of them. Number 8 is the number 8 here. Number 8 should be here. Number 8 is the security I/O interface, should be here. And this one is the heavy load interface, which is used to connect to the robot arm. So for the installation, our proposal is you need to keep some space on both sides because the here's the fan on both sides, air in and air out.
Yes, we have that very clear.
Okay, and this is the air arm for the six-axis robot. This you can find the joint 1, joint 2, joint 3, joint 4, joint 5, and joint 6. And there's on the base, there's heavy duty socket. Normally on the base, there will be a nameplate which will print the serial number. The serial number is important. If you find some errors with the robot, maybe hardware errors, maybe we need the serious number to track the robot production status. And also there are 2 long arm, we call it upper arm and the forearm. This is the end flange. You can use the flange to install the end effectors, for example, the grippers, suction cup, and so on. And for the joint 6, there's an error plug. Actually, you can call it a tool I/O. And on the joint 6, you can also find the end button and the indicator light here. Okay, so for each 6-joint robot, there will be 3 types of joint singularity. So during programming or during teach the points of the robot, it's better we need to avoid these positions. The first one is we call it shoulder singularity. So the joint 5 and joint 6 lies in the plane formed by joint 1 and joint 2, like joint 5 and joint 6. They are on the same plane of joint 1 and joint 2. Okay. The second joint singularity, we call it elbow singularity. It's like the 2 arms, they are straight. It's like joint 3 is 0 degree. So in this case, the robot cannot reach further, so it will cause some error. Third one is we call it the wrist singularity. It happens when joint 4 and join 6, they are aligned, they are parallel in the same. They are aligned and parallel. So in this case, you cannot move the robot in straight line. If you, for example, if you wanted to move to this side, go straight line, it cannot reach. It can only rotate, join 1. So this will cause the joint singularity. This is the range of CR5. You have CR3. Maybe there are some different parameters, so you can find the details from the manual. This is the base installation. So okay, in the quick start manual, and also there's a base calibration paper come with the robot. You need to check that before installation. This is the end flange diagram for CR3. For CR series, start from CR3 to CR16, they share the same diagram. Okay, the next one is for installation. I'm not going to read this rules in very detailed. Okay. So when installation, the most important one is like you need to make sure the base of the platform which the robot is installed needs to be 5 times heavier than a robot body itself. Of course, if there are some specific scenarios, maybe you need to also design the platform according to your scenario. And for CR series, it supports different installation angles. You can install it horizontal, or you can make it hoisting, or you can mount on the wall, or you can mount with different angles. Of course, after installed in different in other poles, except for the horizontal one, you need to configure it from the software. Otherwise, it will cause some errors. Okay, the next one is the indicator and the button introduction. On the joint 6 here is an panel. So here are 5 buttons. So and for different light colors and the light status, there are different meanings. The first one is constant blue light. It means the robot is started and the finish in its initialization and ready, but it's not enabled. Not enabled means the brake of the joints, they are on, and the motors, they are off. So when it enables, the robot light should be green. Here maybe there are some mistake. When it's enabled, when you want to enable it, you need to hold this button for 3 lights. The light will become green will become green steady. So if you want to disable it, you need to press this button for 6 seconds. Then it will become blue. So when you under the enable status, you need to hold the if you want to guide the robot, use the hand guide function. You need to press the button on the middle, so it will be blue blinking, slowly blue blinking. And in this case, you can track. You can use the hand to guide the robot, to drag the robot. So if it's blue fast flashing or blinking, the robot means the robot is just starting, and the robot is or if there are some errors, the robot is not connected well, it will also flash very quickly. So if it's flashing quickly with blue light, it means there's it's not ready. Okay, so when it's constant, it's green, but it's not blinking. So means it's enabled but not running a project. When it's flashing green slowly, so it means it's running a project. So when you want to record the trajectory, you can use this button here, like a camera here. You can press the record button to record the trajectory, and you press again to exit the recording. Then you play the button here, press here, it will play back the trajectory. So in this case, it's blinking yellow slowly. Okay, there are in total 5 buttons. This one is for the end effector. If you want install a grippers which is already in our plugin list, you can control the gripper here. The button on the middle is for the hand guide button. Long press to enter the drag mode. This one, trajectory recording button. Press it and move the robot to record the trajectory and press again to exit. Then you press this playback button to play back the trajectory, just recording. This is enable button, long press to enable more than 3 seconds to enable, and the long press more than 6 seconds to disable. Okay, these are the icons for those functions. Is there any question about the hardware part?
Simon, no questions. You can forward.
Okay. Sorry, and I want to know.
Yeah, there is one question. So these buttons that you showed at the end, can these options be available through the software?
Yes, the software, we can also do the same. Yeah.
Okay. Thank you.
All right. So let's go to the next part. The part 2, I will introduce the control software, and it includes the Windows 1, Dobot Studio Pro, and the CR Studio, which will be used in the tablet. Actually, the functions, they are the same, but the interface, there will be a bit difference. And this presentation is based on the CR Studio. I will introduce it quickly, and later, if you want to know more about the Dobot Studio Pro, I can also show on my laptop.
Okay.
So we have 2 softwares for CR series, Dobot Studio Pro and the CR Studio. The first one, the interface like this, it is running on the Windows. This one is an app runs on the Android platform.
Again, Android.
Android, yeah. And for iOS, actually, we also support iOS, have the same interface as this one, but you need to download from App Store. Cannot be downloaded from our website for the iOS. And
Studio.
Yeah,
CR Studio. Yeah, you can search on the App Store, iOS App Store, Apple App Store.
Okay.
And need to know that we don't have Mac. We don't have the software which can compatible with Mac system now.
Yeah.
Okay, you can go to our website, official website download center to find the software and also the guidance. And this is the Dobot Studio Pro and the CR Studio Pro for the mobile. It can work on the mobile phone or the tablet. So for Android system, you can download from our official website. For iOS, you can download from App Store. For the connection of these two, you can use only Wi-Fi to connect to the robot. So you need to find the Wi-Fi name, the SSID. Normally the name is Dobot Wi-Fi and the model, for example, CR3, and the nameplate serial number, for example, 4328 something. Normally here's 8 numbers. And the default Wi-Fi password is 12 until 0. So when it's connected, you just click here to connect. Okay, this is the CR Studio interface. Okay, I'm not going to introduce here to detail. Later, I can show the Dobot Studio Pro on my laptop. It's easier for the screen share.
Okay.
Okay, the functions, they are the same. Okay.
But can you change the Wi-Fi password for the robot?
Of course, it can be changed. Yeah.
Because that 120 seems very secure.
Yes, and also the SSID can be changed. Okay, I will skip this part. Also in the advanced training, I will introduce very detailed about this software. Yeah.
Okay.
They're using Windows on the right.
Okay, so maybe let's just go to third part. So for basic training, we will spend less time, and for advanced, maybe we will spend more time. Maybe there are a lot of questions you want to ask. So for for coordinate, we have two. The first one is actually for almost all the robots. There are two coordinate system. The first one user system, the second one tool coordinate system. So for the user coordinate frame, we have the base, like the default one is on the base. The center of the base is the 0 point, and the Y direction is the heavy duty cable direction, is the Y plus direction, and the upside is the Z. The other side is X. And for the default tool coordinate, it's on the flange, on the center of the flange. We call it tool center point. So the original direction is changeable, like is keep changing. It depends on the robot gesture, robot pose. But the default Z direction is this direction toward to the opposite side of flange center. Okay, the difference between user coordinate system and the tool coordinate system in our software. For our CR series, we have you can build 10 different coordinate systems. User and tool, you can both of them. You can build 10 systems. So when you are using the when will the user system be used? And it's like when you need to create your own user coordinate. It depends on the application scenario. For example, for palletizing, you can define your own coordinate system, like for the middle of the angle, one of the angle of the pallet defined as the 0 point. So the other point will be easy for you to teach. And for tool coordinate system, normally when you are doing the dispensing, welding, or glue, do gluing, so you can, in this cases, the tool, they are normally there are some eccentric and not straight on the robot end, so you can build the full frame to make it easier for the robot to move. Here is an example. Here is an example of the not tool coordinate. This one should be user coordinate. For example, make the X direction like this and the Y direction like this. Of course, you can also use the tool, like use the tool frame, make the tool frame here on the top of this tool. Okay, this is the introduction, like how to build the user coordinate and the tool coordinate. I will also skip this part and introduce it in advanced training. Okay. So for the user frame, normally we need 3 points to teach the user frame. So for the user frame, normally we need to teach 3 points. The first one is the 0 point. 0 point, we call it point 1, original point. The second one is the X direction. X positive direction of X axis. Okay. So you can teach 1 point, get point 1, and go to the X positive direction to get to the point 2. And then you go to the other side. You can go to either this side or go to this side. It depends on the direction of Y positive. You get the third point. Then the robot will calculate and create a coordinate. This is a user frame. This is tool frame, sorry. They mixed the presentation. There are some typo. This is tool frame, like make the tool frame, make the 0 point on the needle here. I can show you the video. So that the robot can move with different gesture, but keep the tool frame on 0 position. Especially like in welding application. This is CR Studio, how to build the tool frame. I will also show later in the advanced training. Normally we need to get 6 points. So to build a tool coordinate, you need to at least you need to teach 6 points. So you keep the tool points, the top point, in the same position with 3 different poses and get all the points. And then you also get a straight upwards, get a point, and also get B point, move up a bit, and also go to X direction, X positive direction to get the 6 points. So when you get all the 6 points, you can build a new tool frame. Okay, part 4 is about broccoli programming. There are a lot of commands. So I will introduce some of them. So for the broccoli, it's not created by Dobot, our company. The broccoli, it was created long time ago, and we also used this function. It's like a packaged of the script programming, so it's easier to program. You just need to drag and easier to understand. Like is visualized and very user friendly and easier to understand. Here is the interface of CR Studio. So for the broccoli, it's the same as Dobot Studio. So the first one is like the common used commands. For example, move J, like the joint move from P1, P2, P3, P4. So you just drag all the blocks you want and choose the points you have taught. For example, you want to go to P1, P2, P3, P4 like this, or you want to change it to P1, P3, P4, P2, then you just change here. Also, there's a logic blocks for example, forever. You can use this forever block to make it run all the time. And also addition command. For example, if like to check the digital input of the controller, digital input 1, when it's on, you move to a point, else you move to the other point. Or you can also check digital 2. When it's on, you move to point 3. When it's not, you go to the other. Then you enter repeat. Just some simple blocks here. For the point teaching, I will show also later. And also the motion parameter can be changed in the block. You can change the joint speed ratio, joint acceleration ratio, or linear speed ratio, or linear acceleration ratio. You can put percentage, for example, 50% here. So the range is from 1 to 100. So for the speed ratio, the robot running speed ratio is from percent 1 to 100%. The acceleration ratio, it depends on it will define how fast the robot is going to accelerate from 0 to the target speed. For example, here you want to reach the speed here, so it needs to accelerate first, then keep the steady speed. Then when it reaches the destination, there will be also some time and some distance to the acceleration. So need to know that all the movement, the robot start from steady to point 1 to point 2. It need to accelerate and steady velocity and the deceleration. And there are two types of motion: move J and move L. Means move L means keep the TCP posture and move in straight line, like the end point will move in a straight line. Move J means it doesn't concern what is the route. It only move to the target point. For example, the start point is P1, then the end point is P2. So the robot will go to the destination by rotate the joints instead of keep it in linear motion. Okay, here is the for example, here when you use move joint, it will normally will move like this. And if you use move L, it will move like this. Okay, here's a move L. Okay. And you set the speed, acceleration, and also global speed. The other very important command is CP. We call it the CP ratio. When you use the continuous path ratio, we call it CP, 100%. When you move from P1, P2, P3, it will go with an arc here. So the percentage, when the percentage is larger, the radius of this will become larger. Okay. Here is the same motion, but we add CP. And we will see there's no stop between points and points. The robot keep moving and there's no stop. Maybe we can go back to see this one. When it reach anyone, it will have a stop there and start moving again. Then we will add CP, it will become like this. Okay. The other one is relative movement command. The block like this, then and you can choose the point. Then you can input the X, Y, Z direction relative that value. Of course, you can also choose move L or move J. Okay, for example here, if you want to reach the point B, you need to teach. Normally, you need to teach A and go up 2, 3, 4, teach 3 points. And with the relative move command, motion command, you only need to teach 2 points. Okay. So normally you need to use 4 commands, and with relative motion command. Okay, you only need to teach 2 points, and the other 2 points you put the deviation of the value. And also the arc command, the robot move go with the arc motion. The start point means the current position of the robot. The midpoint, you can teach any midpoint. It's not like a half circle here. You can also, the endpoint can be also here, and the P2 it can be any place. Okay, the robot will calculate, controller will calculate the arc and move like this. Okay, here's a demo of the motion. And also for the broccoli, we also have the customized functions, because we cannot write all the all the functions in the block. There are a lot of application scenarios. We cannot cover all the scenarios. So we also have the customized functions. So you can make a variable, you can make an array, or you can write a subroutine to have your own functions. Here is about the variable, create a variable. For example, in this demo is used to calculate, variable A used to calculate. For example, after each loop, I just add 1 to the variable and compare the value. And also there's a function for the new subroutine, make a subroutine. If there are a lot of blocks, if the program is very long, so you can put them in the subroutine. Then, for example, in this program, I have a subroutine called draw rectangle. So each time when you want to use it, you just drag this subroutine. So it will make the program easier to read. Okay, and in the broccoli, there's also I/O control module. And here is the I/O of the control cabinet. So it can be used. It can be used to communicate with the external I/O devices. For example, electromagnetic or other sensors. So there are 16 digital input ports. DI, we call it DI, from DI1 to DI16. And also 16 digital input-output ports. So on the right side, you can define it as input, and also you can define as output. And there are 2 analog outputs and 2 input here. AI1, AI2, and AO1 and AO2. For CR series, the IO port, they are in PNP type. And here also show the ABZ for the encoder connection. Okay, that is not introduced here. So for the IO power supply, you can use the power supply from our controller. You can also use the external power supply. So if you use the internal one, you need to connect like this. So IO0, you connect to 0 voltage watt, and the IO24, you connect to 24 here. So the power will be supplied. So the maximum output for each port, for each port is 500. And then the maximum total current cannot be more than 2 ampere. So if it's more than that, if the requirement is more than that, you can use the external IO to do the power supply for this IO. Here is an example to connect to the external power supply to reach higher current. So the max is 4 ampere. So if there's a power supply from external, you can connect to IO24 and the IO0 here directly. You can also connect the relay to change the signal. Okay, to use the relay, you can transfer it to as we know, the type is PNP. Then with the relay, you can change it to NPN. This is the tool terminal IO, the tool IO description. We support 485 Modbus RTU communication, and also there are 2 DI and 2 DO. So for the DO is NPN type, for DI is PNP type. So when you are using some grippers which need to use the DI and DO, so need to make sure it's on our compatible grippers list. The maximum output of the tool IO, tool DO is 24 watt, and the 2 ampere. But it's less than 1 second. The digital output is NPN type. Okay, so the configuration of the IOs, you can also it can also be get from the broccoli. So here, for example, you can use the command, the block command, wait digital input. This one you from the controller. You can also choose from the tool. For example, DI1 on. 0 seconds means 0 seconds means the overtime. Like if you like, if, for example, you put 5 seconds here. If after 5 seconds it didn't receive the command, didn't receive the signal of DI1, it will go to next command. Okay, if you put 0, it will keep waiting here. And also you can this one is wait input. And also you can set output of the controller, for example, DO1 to set it on. So DO, you can set DO1 to 16 for control cabinet, and for DO1 and DO2 for terminal IO. For example, here it's like use the button connected to the IO. When the button is pressed, the robot move to the position 1. Okay. Here's a simple example. Like we start the program and wait digital input from the controller. Digital input 8. This one depends on the wiring. So it's from DI8. When it's on, so we move to the home position and do a relative motion, like the delta Z is 50 millimeter above the peak point. So it will move to the peak point up and go to the peak point. Then we also set the digital output controller, which is used to control the suction cup. Set it on, and you do the same movement to the other point. And when it reach the destination, you set the output off, the suction cup off. Then go back to the home position. It's just a simple demo for the IO distribution. Okay, it's the same contents. We also have analog output and analog input. So the value, you can put analog 1 or 2. The value you can set the value, depends on the definition of your analog signal. And also you can get the analog input. Okay. This is our training platform, so I'm not going to show here. The IO definition of the training platform. So it's only for like not for the online training. Okay, the next one is for the calculation commands. You can use different calculations, arithmetic calculations, and also comparative operations, and also the logic and or not, and also the print command. Normally we use this to do the debug, or if you want the program to print something when it reaches some point, or when it finishes some task. So for the printing, there are 2 types. The first one is synchronous printing. So it will wait until the other commands before it has completed, so it will print. If you choose here as synchronous printing, so once the program is running, it will print out. For example, here, the first one I choose sync print. So the robot will move to these points. When it reach point 4, then it will print hello world. If I choose a sync, so once the program start, it will print hello world. So in this case, the robot is still moving. Wait command, you can use this wait until the other condition is met. And repeat, you can repeat the program for many times and forever, and also end repeat. Once some of the condition is fulfilled, is met, you can end and repeat. If this condition is flagged, then you go to this, else you go to this, similar as this one. Pause, the pause command, once you use this, the robot will, the program will pause and you need to click to continue. Sleep, sleep means the program of the robot controller, it will sleep for some seconds. Move wait, it means the robot will stop moving, but the program will still scanning. Okay, this is the for the training platform, not for the online training. But the demo also shows something. For example, here in this program, they used subroutine. They used 3 subroutines. The first one is initialize. So when you are doing some programming, you need to make sure the robot go back to the home position first, or all the IOs and all the signals be made to the original one. And also there's a subroutine for material control and move action. And for the for the loop, it's easy. They just defined the reliable to compare the reliable. Okay, it's here. For the initialize, they make all the speed to the target 1, and also make the reliable to 1, and also turn off all the signals and move to the home position. Here is the subroutine 1 here. And the material control, like to control the IOs to make the materials and the conveyor belt to move. Here is for the movement, just compare the reliable here. Okay. Maybe let's just finish the part 5. Okay. Then we can have a break. For the system I/O, we support remote I/O control. I will also show it in advanced training. Like in the Dobot Studio Pro, we can set a remote control mode. There are in total 4 modes: online modes, remote I/O, remote modbus, and a TCP/IP secondary derailment. So when you choose the remote I/O, you can use the I/O wiring and the remote button to control the program to run. For example, here, there's a program named 1111, and you can configure the I/O signals. Okay. For example, the start, you choose which one, choose DI1, pause DI2, for example, like this. Okay. And also there's a safety I/O, you can also configure it. For the safety I/O, there are 6 functions here. Reserve means it's nothing, and the user emergency stop. You can connect your own emergency button to use this function. And the safe stop. Safe stop means stop the program, but the robot there's still power supplying, but the emergency stop will cut the power. Safe stop reset. So when you configure a safe stop, you need to trigger this signal, then the robot can recover. Reduce mode, you can reduce the speed. For example, there's a safety door or some other sensors. When the signal is triggered, so the robot will move in slower speed. run confirm means just confirm the robot status is in running status or is stop status or other status. For the safety IO, there are 10 SO and 10 SI, but part of them are occupied internally. So for example, here, you want to put an emergency stop input. So you need to get the power supply from SO2 and SO4. This wiring diagram, there are some specifications in our user manual. It will show what are these in what are the definitions of this of all of these IOs. For example, to control the safety, to connect to an external safety emergency button, you need to use two DI, two SI and two SO. These two for the power supply, these two for the signal input. For all the safety system, we need to use a backup, like two line parallel to supply. Make sure the each of the signal power is cut, it will trigger the safety stop. This one is a safe stop input. If you configured the safe stop reset, so you need to connect another reset button. Once this one is triggered, so you need to connect it again and press here to restart the motion. Okay, the safe stop reset button. So the default input of the safe stop reset button is a high level. So it's normally open for the reset button. So once it's triggered, it will once it's triggered is a raising edge. It will trigger this signal. You can also configure it. You can also configure the reduce mode. Use the same diagram. When it's triggered, the robot will go to reduce mode. This is the diagram for the auto run. It's similar. 2 and 4 is power supply. Actually, 2, 4, 10 is power supply. This is emergency stop status output. So for the output, you need to use the 0 volt from the general IO, because these are output, and we need to connect to the other 0 volt on the top of the IO board. So this one, for example, it connected to SO and safety IO, safety output 03. Okay, for the other functions, also the similar. For all the output functions, also the similar. That's all for the basic training. Very simple introduction. And there's any questions that you can ask now. We can have a break for 10 minutes. Then we can go ahead with the advanced training. We will spend more time in the advanced training. Sorry, there's some noise from my side. Can you get my clearly?
Yeah, your voice is clear.
All right. So if there's any questions, you can ask now about the basic training. If not, we can have a 10 minutes break.
I have a question. So you talked about the emergency stop and the safety feature. So in addition to this, are there any sensors on the arm itself that can make sure that if it's like hitting some object, like an obstacle, then it would avoid it or not hit? So, I mean, is there any safety on the arm itself, built-in safety?
Yes. On the arm, we have the collision detection. There are 5 levels of collision detection. I will introduce it in advanced training. And also in your table, there's a robot with safety skin. It's also a function of the obstacle avoidance. Yeah.
So there are sensors on the arm itself?
And actually, we don't use sensors in the arm itself. We calculate the power, the current of the motor. So once there's any collision, when the force is bigger than some value, it will trigger the stop.
Okay, and that kind of sensing is distributed. So any point on the arm is, if it's hitting an obstacle, it would detect it, right?
Yes.
Okay.
When it reach the reach the preset force value, it will stop. Yeah.
Okay. Thank you very much.
All right.
I have a question. Is related for the safe skin, like, you know, we have this robot in the very close small space and we have the student working on it. So how safe the robot is, like, I read before that, like, there's a 10 centimeter distance that, like, it should not hit the user. So what is the understanding of this safe skin?
For the safe skin, you can define the distance, like the maximum is 15 centimeter. It's like when it's near 15 centimeter, the robot will stop. And also you can configure it to 5 centimeter. Is configurable.
Okay, so meaning it has to be programmed, huh? not by default feature.
We don't need to program it. Yeah, for the safety, you can set it directly on the plugin.
Okay.
For the safety skin, yeah, there's a Dobot Plus. You can just click to configure it, then run the program. Yeah.
If there are any student have question, you can unmute and directly speak. Yes, Tariq.
Assalamu alaikum.
Salam.
When I was looking at the setup, I saw they have different types of tables. So, and I say in the lab, we don't have the proper setup. So does the table come up with this, or how do they set up this robot to perform the intended task, means they're promoting for?
The one we have in the lab now is just a temporary setup. I know it's not the ideal, but later we will do the proper configuration. So, Simon, you can answer this question.
Yeah, of course, the one I can see on your table is not correct. I think the table is not very stable. It's better you have own. You need to have your own platform, and the base, the weight of the base at least need to be 5 times than the robot weight.
Thank you for the answer.
Any other question from the students? just a quick note, we record this session, and later after the training done, we will upload it to our CI department YouTube channel. So any one of you who come late, you can refresh and visit our YouTube channel.
All right, if there's no more questions for basic training, so we can take 10 minutes break, maybe. And after 10 minutes, I will continue with the advanced training. And for advanced training, I will introduce more detailed, like for all the functions of Dobot Studio Pro, I will introduce to you.
Okay,
Okay, Simon, we can meet after 10 minutes.
Okay, thank you.
can pause it.
Okay, hello.
Yes, Simon.
Okay, it seems you can get me. So let's continue with the training, advanced training. And for the easier presentation, maybe I just show my whole screen so that I can share other softwares also. So the second part is about the advanced training. Mainly there are 5 topics. The first one is I will introduce the Dobot Studio Pro, and I will also show it in my laptop. I've
Simon,
connected a
you
robot
were-
with.
Simon,
Sorry.
yeah, your voice is very low.
How about now?
Yeah, now it's good.
Okay. So there are 5 parts for the advanced training. So for the first one is the Dobot Studio Pro. I will introduce the in my laptop, and I'll also show all the functions in my laptop. And the second one is Broccoli programming. I will show the blocks which has already been introduced in basic training. And the very important part is part 3 and part 4 about the communication protocol, Modbus and the TCP/IP. Maybe some of you guys already learned something about that, but for our robot communication, you can also try to understand how we build the communication and how to control the robot. And part 5 is about Lua script programming. In our control software, Dobot Studio Pro, we are using Lua script programming. Lua is the language we are using. Okay, the first part, Dobot Studio Pro. The same software just showed. Okay, so when the hardware is connected, like the robot connected with the controller, a robot controller, and you also connect the controller or the robot with your laptop or with your tablet or with your phone. So to build up the communication, you need to make the network in the same segment. For example, here, for example, if the robot is connected with the network cable to your laptop, so defaultly, you need to modify the computer adapter IP address to 5 segment because the default IP is 192.168.5.10, and the subnet mask default is here. So it means the third one, 5, is the segment. So you need to modify the IP address of your computer adapter to the same segment. And maybe I can show here. Okay, I've exited the full screen. So you need to go to the Ethernet, change your adapter options, and find the related adapter, choose the properties, and find the internet TCP/IP v4. Some of the words are in Chinese, but I think you still can read because also written in English here. So you change to the 5 segment. My robot is using the default 5.1. So you choose, so you use 5, and the other number you can choose anything like 5.2, 3, 4, and less than 255. Okay, then okay, then close. And in this case, you can, try to ping your robot. Okay. Okay, input your robot IP. Okay, you get reply from the robot. Okay. So it means you can connect to the robot now. This is the same thing I introduced. In our robot, we also have the share folder for our CR series. like all the settings and all the projects, they are set, they are saved in these share folders. So when you can ping, like when you can reach the Dobot, so you can also enter the share folder. Before that, you need to make sure you have you have closed the like some antivirus software or the firewall. So you press Windows and R to get the run command here, and input Dobot IP. Note that the stroke here is this one, not this one. Okay. Also input the robot IP, then you can enter the share folder of the robot. Here is the project, the main folder. And go inside, you will find there are logs. Okay, and there are a lot of details inside. And go to all. There are logs for the robot, which is created. Okay, you can copy it to your robot to the desktop. If there are some errors, maybe we will ask you to share the logs so you can get from here. Of course, there are some other settings and the projects. All the projects for this robot will be here. Okay, and for the settings of properties and the process, these parameters it's not recommended to modify it. Okay, just if you want to modify anything of them, you need to inform us. This is for the Wi-Fi connection. As introduced is the default number. Okay, here is the robot name, the SSID, robot Wi-Fi, CR3, and there are 8 numbers here, and you input the default password. You can connect. Okay, I'm not going to show here. Okay, so when you connect it, you open the Dobot Studio Pro here, like this one. Okay, so when you connect it, it will show this interface, and it will show the robot ID here, CR3, and the IP address is now disconnected, right? So if you are using the default IP, it will show here. If you modified it, maybe you modify to 10 point something, so you cannot find it. So you need to go down to add it manually. For example, you modify it to this segment, this IP. You need to add it. I'm using the default one. Just click and connect, and you can connect the robot, and it's showing here. This is the current pose of the robot. Okay. So all of these parts, I will introduce it detailed later. Just go skip. Okay, so let me open this one to introduce. So on the top here is the version Dobot Studio Pro. I'm using the latest version here. For this software you can download from our website, and here is the menu and the home page. Okay, already on the home page. And on the left side here is a recent projects. I have built some project for this training. And on the mid, okay, here you can fold it. Okay, middle here, there are broccoli programming, script programming, settings, and process. On the right side, there's control panel. You can click to see. Let me introduce one thing again, because maybe some of you guys, you don't have the real robot with you, so you can also try to connect to the virtual controller. But this function is for our internal use only, like for still under debugging period. But you can try it in our CR series, CRA series. We will release a formal official function for the virtual controller, but the functions, they are similar. So if you don't have the real robot, if but have the laptop and downloaded the software, you can even connect now. Okay, and it will show the permission logging is using the random code. Okay, I will show you how to calculate, but normally it's only internal use only. But since you don't have the real robot, some of your guys and maybe there are some students, so I will also show this function. So you open the calculator, find the programmer, okay, and the input this code 397396, and choose bitwise to choose all, and input 4353. This is the fixed 43534. Any robot for our from us, then you get the result A073. And you can log in the virtual controller. You can also use the software, right? And it's easier for you to try some function. For example, broccoli. You can also use the broccoli. Okay. Okay. This function just for our internal function. Okay. And here now I'm connecting to the real one. I disconnect this one. So I connect to the real one. CR3 here. Okay. The control panel, here you can find the user frame. And here you can choose different user frame and the tool frame. Okay. And then the robot current posture here. Okay, let me try to move it a bit, and you can see need to enable the robot first. Okay, it's moving, right? Okay, these panels are for the manual motion. Like you can choose user under user frame to move it, or you can use under tool frame to move it, or you can use jog. It means continually motion. For example, I wanted to move to the X direction, continuous movement. Okay. For the step, I can choose 10 millimeter. Okay. The unit is millimeter. You can click once, it will move 10 millimeter. Okay. These are for the teaching. For when teaching point, you need to use these functions. The second one is I/O monitoring. Click to see the controller I/O, tool I/O, and the save I/O. You can configure it here. For example, DI, DO here, and go rolling down, you can find the DO. And also analog output. For the tool I/O, there's a diagram showing the functions here, and the safety I/O. Okay. For the Modbus, here you can check the status of the Modbus registers. You can click here, connect. For example, connect to this the same robot. I get the choose the coil status. Okay, so I can find the address from 1000 and 1006. Current status is 1. 7 is 1. Okay. Then the global variable you can use to you can add some variables. For example, variable 1, I put int, then value I put 10. Okay, global hold means these values will be will be affected for all the program, and when it's changed, this value can be changed. Okay, like this, and also you can add some other types of, for example, string. Okay, like this. And for Dobot Plus here, you can add the different plugins. But currently for CR series, only these plugins are available, which like Jodel, the Grippers, one of Chinese brand, and the Arstone Tech for the 3D camera, and the force torque sensor. There are 2 types of Chinese brand and available. Robot IQ, Grippers, Okay, and the save skin, the one you just asked, you can click here to install. Okay, save skin, and you can configure it here. And also the terminal IO. Okay, other plugins. Okay. And the next step, let's go to here. Here shows the robot type, IP address, connecting status, and the save level. The one you just asked about how the robot will detect the collision. So current the save level is level 5. This one can be changed but later. We need to go to the setting. Online means the current robot mode. As I introduced, and there are different modes, 5 modes online, 4 modes: online mode, Modbus, TCP, IO mode, and the TCP IP secondary development mode. There are in total 5 modes, different modes. And here's the log. When click, if there's some errors, it will show here. And also here you can see the machine status. Machine status like the current time. Okay, you can modify the time. I just keep the default one. And the joint status. Okay, for the each joint, the current voltage, temperature, and so on. And here to enable and disable the robot, as I introduced, once you want to run the program, you need to enable the robot. Enable means the brake is released and the motor is on. When you disable it, means the brake is on, the motor is off. So when you want to enable it, it will when you click here, it will pop up to show you like you need to set the end tool load. You need to put the load parameters. If you didn't put anything, or in my robot, I put something, a sanction cap, we just put 0.2 kg. And there for the centers, there's just put 0. If you put something heavy or there's some offset, so you need to follow the load curve. You need to follow the load curve. You need to follow the load curve. Let me find the load curve. Maybe in Chinese. For example, CR3 here. So if you install some tools, for example, a sanction cap or a gripper, there are some eccentric to the Z value, so you need to follow this curve. Okay. Defined from the manual. So once you configure it, you just confirm modification, then the robot will be enabled. And when it's enabled, you can control it. The speed, global speed, you can adjust the speed here. Adjust the speed here to set the global speed. Okay. So when you are doing some debugging, we propose to use slower speed, maybe 30 or 20%. Stop. For stop, the stop button here means the emergency stop, but it's from software. I can try it here. When you click here, so it will show the emergency stop button is pressed. Okay. So when you want to read it, so in this case, the robot, there's no power supplied to the robot arm. So you need to clear alarm first. Okay. Then you power on again. So the robot will take some time to power on. Okay, we can go ahead and maybe wait 30 seconds or 1 minute. It will be powered on. Okay, so that's all the parts of this software. Let's go back to check. Okay, so now it's steady on. Here it will also show the robot status, the light indicator status is steady on. So what it means the robot has been powered on and it can be enabled. So you just click enable, and it will also pop up to tell you to configure the loads. Okay, so it's green now. Okay, it's green now, and the robot itself is also green. The the second one is let's go to the broccoli here. When you click here, it will go to this page. So you can drag the commands from here. Okay, if you want delete it, you can put here, or you can just go to this side. It will go disappear. Okay, but the start, this one is default. You cannot delete. It can also be deleted, but it's generated automatically. Okay, so each of the project you need this one start, and here make it zoom for bigger, smaller, and go up. Okay, go to the like this. Okay, go to the middle, and for the edit, for the lock. Okay, so you can choose more. You click here, edit. Okay, and you can check all. You can copy. You can delete. All right. Then you go to the home page. Do not save. The second one is script programming here. You click, then you come to here. Here are some basic commands. You can also search. For example, you search move. So all the movement command, it will come out. Okay, search IO. All the IO commands will come out. And also you can read the, if you have questions, you can click here. Like it will show you how to use these commands. Okay. And let's go to the process first. So for CR series, we have full process. The first one is trajectory playback. The one you just asked about, can we use the same function in the software? Is you can use the new here, like you can create new trajectory. So when you click new trajectory, so at this time you can drag, like you can drag the robot, right? And you save check. Okay, then you can play back. I just click here, play back. Then the robot start moving. Should be this one. I choose the long one. Okay, this is the first process. The second one is screw driving. This one should be used together with our demo platform. So I cannot show here. So for example, I can, okay, it's a for screw driving applications. So you need to compare, connect it to our platform. And also there's a conveyor tracking. It's also for our, you need to connect it to the conveyor belt. Then this function you can use. And for palletizing, so it's only for this palletizing station. Okay. So most of the function in the process, maybe you are not going to use in your daily applications. Then the very important part about the settings. Let's go to the settings. So you can enter settings from here, or you can also enter here from the menu. From the menu, you can enter the settings. You can change the language. You can get the help documents, and you can check updates. But actually, the update, we have our own update tools, maintenance tools. So we normally don't use this one. Okay, so let's go to the settings. So for the settings, there are many settings here. The common one is like you can change, or you can turn on the Dobot link. Sometimes when you are connecting to the robot, you cannot see the robot here, Dobot IP here, and you also cannot see the virtual controller. Like nothing is showing here. So it means the double link is not turned on. So you can turn it manually, turn it on. So the double link will show. Just close it here. Then let's go to the basic setting. Here you can check the box here for the automatically connection. And here, the device name and the version details. This one is the software version, which is also showing here, and the controller version, the 3561 stable. This one is the currently the latest one is 3570. Okay, device serial number. Because this software developed later than the it was upgraded later, so the device SN is not yet here. For the new machines, it will show here, and also the other versions, which are important, is the servo versions. All the versions can be here. If there are some problems with your robot, maybe we will ask you to share the version page. So you need to go to the basic and get all this, get a screenshot of these versions like this. Okay, the next one is communication setting. Here you can modify your IP address. So it shows only IP address of LAN 1 can be modified to connect external devices. So you need you can modify it to the one you wanted. Okay, except for 1 and 100. Here you cannot put 1, or you cannot put 100. It's occupied internally. But we can also help to configure it if a lot of device in your place is in 1 or in 100 segment. And for the Wi-Fi setting, you can also change the name of the SSID, and also you can change the password, default password here. After changing of this, you can connect directly. But after changing this, sometimes you need to restart the controller. For the next one about the control coordinate system, they are user frame and tool frame. Okay, so as I introduced for the user frame here, we support in total 10 from 0 to 9. So you can choose any one of them, then you just modify it. Then you can input. You can use 2 ways to do the configuration. You can input user frame, maybe the name is new, and you can input if you know all the points. If you don't know, you just choose this one. Normally we choose the 3-point settings. So you want the robot to is 1, 2, 3 points, and obtain all the points. After everything is done, for example, I just do something quick. Okay, when you get all the 3 points, just click OK. Okay, here shows calibration field because all the 3 points I just get in the same position. Okay. For the tool frame here, you can also do the same, modify. Then there are 3 ways. Normally we use 6 points setting. You can also use 3-point setting, but 6-point setting will be more accurate. So you also do the same with different holes to get 3 points. 1, 2, 3. And you also get 0.4 when it's straight. 0.5 up a bit. 0.6 go to X direction. Then you click OK. Then it will generate, then it will generate the coordinated system here. For example, I choose 1, which is already done. Okay, so here it's already get 6 points. Okay. You can like try to create user and the tool frames when you got the machine, got the robot. Need to know for the virtual controller is not supported this function. And the next one is load parameters. The similar page as the one when you are going to enable the robot. Okay, here I put 0.2 kg. Okay, you can also modify it to the correct one. Need to note that cannot cannot put the wrong value. For example, if there's a CR3 but you put 5 kg here, it will cause problem. The robot will run very abnormality. The next one is motion parameter. And here there are two settings. The first one is jog setting. Jog setting means when you set the speed here, then when you are using the motion command here, motion panels here, the speed will be following this one. Of course, it will also follow this one. Okay. So the final speed is this speed multiply this percentage here. Okay. So joint velocity and the joint acceleration and the joint coordinate velocity and the coordinate acceleration. You can like modify this. And also you can use this one to go back to the default value. Okay. The more important one is the next one here, playback settings. So the values here means the value when you are running the program. For example, the joint velocity, joint one is 180 degree per seconds. And here you make it to 50%, okay? And in the program, you make it to 50% also. So it will become this one 180%, 180 degree multiplied by 50% and 50% again. Okay, so it's 45 degree per seconds. So if you want to get the right speed, you can check here. Of course, this value can be changed. Okay, yeah, this one is for drawings. This one is for the coordinate system. Okay, it can be changed. The maximum, you can input the maximum value to try, but it's better use the default one. Click here to go to the default one. Okay. The next one is for security setting. Here we have five modules. The first one is collision detection, the one I just mentioned here, the safety level. You can choose the different levels. Collision detection map here. So if there's a touch or collision of the robot, you can choose different level. The higher level means higher sensitivity. So level 5 means it's very sensitive. You don't need to engage a large force. The robot will stop. Level 1 is you need to engage a large force. For CR3, it's about 30 Newton. Okay, here I choose 5. So in your teaching, I like for the daily lessons, I propose you just use the level 5. And also the processing, the post collision. It means when there's collision detected, what the robot need to do. Okay, it's better you choose stop. Okay, you can also choose pause, stop or pause. Okay, and you can also choose enter drag mode. It means when there's a collision, the robot will enter drag mode. You can drag the robot, but there's some risks because when it's entered the drag mode, if there are some loads, if there are some grippers load on the robot, it will fall down. So we don't recommend to use this function. Enter fallback mode, it means the robot will go back a bit. In CR series is not supported here. So here you can choose stop, pause, enter drag mode. Okay. Here are also a tip, like for the some controller versions. Okay, some of them are not supported. Only 350, 354. You need to check your controller version. And the robot in your office is with the safe skin. Some of the safe skin robot cannot be upgraded like as to the latest version because the safety skin has a special plugin. So you just keep the current version. Okay, the second one is articulated brake. It means you release the brake. Okay. When it's not when it's disabled. So here, if you want to open the brake of each of the joints, you need to hold the brake. For example, I can lose the brake of joint 6, then it will tell me to disable first. Okay, I disable it, then I open the brake of joint 6. Okay. Then here joint 6 is open, then I can rotate it, and I can rotate joint 6 manually. Here you can see but this function is normally is not proposed to use these functions, but only when there's some emergency or the robot cannot be moved, so you can open the brake to move it manually. And the third one is installation. This CR series we support different gestures like hoisting or the top, like wall mounted and wall mounted the other side, custom angles. Okay. When you choose each of the installation angle, need to make sure the robot is in the right position, in the correct one, and you need to click here, calibration. The robot will do the calibration by itself. Otherwise, there will be some errors to tell you the there are some collision or something. So in your daily lessons, I don't think you need to choose this to use these functions. You just need to know we have these functions. And for the sensitivity, you can adjust the each joint sensitivity by using this one. It means when it's in drag mode, when it's in drag mode, is the resistance, the value of the resistance. Okay, so when you like the smaller the value, the greater the resistance. For example, I put to like this, so it means it will be very heavy when you want to drag it. Okay, you can also make it 100% or 90% to make it easier to drag. To use the teach mode, for example, here. So if I want to drag the robot, it will be easier. I'm now long press the robot. For now, it's easier. Okay, let's go to middle one. And the next one, advanced features. These features only for our like technical support, but also you can get I can tell you the password. 668. So you can sum all the functions because it will be easier for us to do some debugging works. So you can log in to check some of the functions. Okay. So this configurations is better you just keep it. Do not change it. Do not change it. If you want to change it, it's better to tell us. True motion. There are some explanations of these functions. The first one is true motion, and dynamic optimal compensation. Compensation. Make sure always keep it on. And there are some vibration suppression. Sometimes you will find the robot there are some vibration, so you need to make it. You choose mode only mode 1 now, and the start stop vibration suppression. There are some for the vibration functions. Okay, so this normally you don't need to use, but sometimes maybe for the debugging or for the troubleshooting, maybe we will need your help. Go to this page. So you need to know this page. And the next one is for the remote control. Okay, the current mode, like for our robot, we have these 4 modes. The first one is online mode. It means you can do the programming. You do the programming and run it. The second one is remote I/O. So you can use the I/O, external I/O, to control the script or control the locally program. For example, you choose any one of the program and you modify. Then I use DI15 to control this program to start, pause, or resume or anything here. And also it will output some status like stop status. It will go to DO 13, or you can also configure it here. Okay, just for an example. And also you can cancel. Okay, you can use a remote model bus. So you can use model bus to control the, for example, you can control this project. Then you can configure the coil registers and also the discrete. We also call it contact registers to control this project. Okay, for example, start, pause, resume, anything. And for the model bus remote control, we also support. You can go to the advanced. Cancel. You can go to the advanced setting. You can also control many programs at the same time. Not at the same time, with different register address. Okay, for example, register value. For example, the whole register value is start from 1000. So the 1000 and 1000 it controls. Let me put one. It's easier. 1001 it will control this program, and 1002 it will control this program. Okay, let me use some named this. Okay, 1003 it will control this program. So once there are different inputs of the model bus address value, it will run different programs. The fourth one is the TCP/IP secondary development. So once if you want to use your own interface or develop your own software, so you can use the TCP/IP secondary development function. So make sure you turn it on here. Okay, once you turn it on here, it will show here TCP/IP mode here. Then you can use the secondary development tools to do the development. For example, you want to use integrated with loss, integrated with use the MATLAB or some other language. Okay, let me go back to online mode. And for the TCP/IP secondary development, we also have our protocols like the interface API, the details in our GitHub. I can share it later in the chat group. Okay. The next one is firmware update. This function we are not using now because we have developed a better software for the firmware upgrade. So this function you don't, please do not use it. It may cause some problem. And for home calibration is also a factory function. Okay. But if there are some heavy like collision or something happened, make the robot lose the 0 point. Maybe sometimes maybe there are some hardware issues. You need to replace the robot joints. So after the replacement, you need to do the home calibration. Okay, we have the same password. Make sure all the joints goes to 0 position, goes to 0. Like here is showing the position. Okay, for example, join 2 now is near 0. Make sure all the points goes to 0 position. And the robot will be straight. And you need to dismantle all the any tools, any effectors, and you click here home calibration. So the robot will get the 0 point. And the last one, manufacture function. These functions are not open to you guys. So it's only for some big problems. So or for the factory usage. So we can do the auto identification. Like the robot will run some program to identify the the dynamic servo value. Okay, And for the collision detection function, its default is on. This one, you can turn it off, but it's better to keep it on for the safety consideration. Okay, so that's all for the introduction of the interface of the control software. And any questions from you guys?
Yeah, I have one question. You mentioned when you mentioned about the TCP/IP. If I hear correctly, you mentioned about possibility of interfacing with MATLAB. Am I correct?
Sorry, MATLAB, yes. Let me check from our GitHub latest one is MATLAB or LabVIEW. Check. So you can go to here to check TCP/IP protocol.
We do have both. We have license
Yes,
MATLAB, and we have also
MATLAB.
LabVIEW.
Yeah.
Okay. Yeah, we will look into the documentation and see if we can develop with the MATLAB also.
Dobot link LabVIEW. TCP CR LabVIEW. Yes, also LabVIEW also here. Yeah.
Okay.
I will share this.
But we leave it for the next level. For now, we just learn the basic first, and then later on, once we got grip on it, then we will integrate also with MATLAB or LabVIEW.
No problem. Okay.
Any question from our audience, students, professors?
Thank you all for this opportunity. My question was that in the beginning you enabled the virtual robot. I couldn't see that when you use the calculator. Is it you added for the random code, or what was the operation?
I can show it again. You just use the calculator, right? And here you'll find the virtual controller to connect. Sorry, because I already connect once, so it will connect directly. Let me close and open again.
Simon, why do you have to use the calculator? I tried before using the just the code generated. I just put it at work for the virtual.
No, when you open it again, it will disconnect. You see here.
Is it?
And here's another random code, so you don't know the password. Okay, so when you click here, 1598. So you use the calculator to input it. Or then input 4353. This 4353 is fixed. Okay, you get this figure 5951. Okay, every time the running code is different, so the password is different. Okay, it's now connected. But I need to specify is that this function is only for our internal use. But because some of the customers maybe they didn't get a lot of a robot, so they can also try this function. But actually speaking, the functions are not very optimized. There are still some bugs. We will do a very good version in CR3 series. It actually is going to release very soon. Yeah. But you can use this one to do the programming. For example, you want to do some program here, or you want to do some program here. Then later you can try it with real robot. But make sure you need to use the same model. Here is CR5, right? If you have a CR3, so maybe the points maybe they are different. They're different. You need to teach the points again. Okay.
Yeah, all good. Thank you.
Okay.
So, Simon, so the idea is that our students, they can download the software and they can get familiar themselves using this virtual, right?
Yes, yes, yes. That's what that's
And
why I show
it
you
is
this function.
available online on your website. Our student can download and they can program on your laptop, on their laptop, on their smartphone also, right?
Yes, yes, yes. But you need to download. It cannot be done online, right? You need to
Yeah,
download.
yeah, yeah.
Go to our download center. Yeah, then you download the control software. Find the same version as mine. Should be. Cool. You can download this one. This one will be better. Dobot Studio Pro 271. This one. Okay.
Yes. And all the PDF, everything is there. So the student
Yes.
they can
Yes.
study the manual online, right?
Yes. I also share this link to the chat box. Okay.
Thank you.
Do we need to take a break again? Already 1 hour past, I think.
Yeah, we can continue, I think.
So let's take a break, maybe for another 10 minutes. Is it fine for you guys?
Yeah, fine. We can take a break.
Okay, okay. Let's take a break. Then we will come back after 10 minutes. I will go ahead with the training. Thank
Okay.
you. Hello. So let's go ahead with the training. Can you hear me? Hello, can everyone hear me?
I can hear you, sir.
All right. So let's go ahead. So I just introduced the basic like interface of our control software. Then the next one is about the broccoli. Actually, I also tried to open it, but I didn't go to very detailed. So for the broccoli, there are many functions. You can find the functions on the left side. For example, event control. Okay, for the operators. So any questions, you can also click here to find the explanation of all the blocks here. Okay. Here you can find the functions, and you can close here. And for the string, okay, custom, you can create your variable, number variable or string variable. These are the global, these are the local variable. Okay, if you make a variable here, so you can also create the global variable here. And of course, you can also make a function. Like you can add a function, like define a function for some special functions. And you can define the functions. Okay, and also you can use the motion commands, okay, and the Modbus communication, TCP/IP communication, and for the Dobot plugin, we have DH grippers, and the on-robot grippers, and for the safe skin, set it on, set the obstacle avoid on or off, okay. And also we have our welding applications, okay, but this needs to be to be installed a special version for welding machine. Or and he shares another function like for the for the script command, you can also transfer it to for the broccoli command, you can also transfer it to a script. For example, here, for example, I build a program to move. Just do a simple movement between. You can copy. You can duplicate it. Okay. Then repeat the 3 times. Okay. Then I teach 2 points. The current point. Then I go to I run a bit to x direction, to x minus direction. Okay, it moves. Then I add another one. So it's P1 and P2. You can also put the areas. Maybe you put the home position here, and you put target position here. Okay, then you can move joint home with target position. Then you save this project. Okay, Control and S. Okay, or you can click here, save. Test. Okay. 22. Okay, it's fine. So when you set this project, you can debug. You can click here to debug. Let's for the debugging, you can make the speed lower. You can click here debug. Okay, run it. Then also you can click here to get the script. Okay, so in Lua script, it's like this. Okay, and for the debug, you can do it step by step. So you click, and it move to the home position. and move to the target position. Okay. Exit. And also you can click the start, and the robot start running. Okay, here are just some very simple command, very simple demo. And when it's moving, you can also make it 10 times. Save. Okay, when you modify anything, you need to save, then start. Then when it's moving, you can still change the speed, make it faster. Okay. Yeah, I put too much speed here. Maybe it will cause some error. It depends. So when it's running, you can click pause to pause, resume to resume, to stop the project. Click script to convert the script. Okay. Pause, stop the script. When you click pause, it will become resume. Okay. The second part for the broccoli programming is advanced applications, but is this one is for our training platform. So you don't have the platform there, maybe you cannot try this function. But it's also like some simple like control the to control the conveyor belt, and also control this. There are some sensors. When the workpiece reach the sensor, the controller will the conveyor will stop, and the robot come to pick. Of course, we also have the conveyor tracking function. It's like the robot move together, follow the conveyor belt, and get the workpiece. Okay. So since you don't have, so I'm not going to introduce a lot about this function. These are just an analysis about during the program how to do this program. So normally we have the initialization program and detect the material, and also have pickup and the palette configuration and place subroutines. Here are the programs. Okay, maybe I just skip this part because maybe you need more time to do the practice, like you know how to do the programming for the broccoli. Okay. First part for the initialization. Set the speed. First you print start initialization. Then you put the speed, and also you make all the IOs off. Then move to the home position. Then you print initialization finished. Okay, here you create a subroutine. So for the start, there are two. The first one is the main program start. The sign of the main program start. The second one is subthread start. To start the subthread. So this subthread and the main program, they will run at the same time. So normally the subthread is used to detect the IO signals, and also you can do some modbus or some other logic consideration, logic checking in the subthread. So make the program to run parallel. This is the material detection. Okay, and this because this is for the specific program, so I'm not going to explain it. Okay, this is for the material detection. We use the IO to do the detection. And the pickup subroutine. You create a subroutine, then do the pickup. And we also have the palette block. Okay, it's here. You can, if you have some simple advertising works, you can use the palette command here. Okay, you can drag this one, the palette one, then you click to configure it. You can configure it to different dimensions, for example, 2 dimensions or 3 dimensions. Okay, and you input the number, for example, 5, 5, 5, 5, 6, 5, 6, 10, 10, 6, 10, 6, 5. Okay, so the number of x direction will be 10, number of y direction will be 6, number of z direction like 10 layers. So for the 3 dimension, you need to teach at least 8 points. Just follow the steps to teach all the points here. Okay, for example, point 1, you can drag the robot to select points. When it's done for all the, for example, I just, okay, you can just go to point 2. Okay, when you finish all the teaching all this of these 8 points, you can save it. Then in the program, you can call the palette function. Like you can get the palette point count, like how many points are there in this palette, and you can get the palette point. Then you input something here. This is the palette function. Here, this one you can get the palette coordinate. You input the name and then the number of the points. Okay, also shows the same thing. For the placement, it also has a subroutine here. Just some simple motion and get the palette. And there's a number variable. So the final program is here. Like in the beginning, we create a palette, and in the subroutine, we have our initialization program. Then we have our customized initialize number, variable number, put it to number, put it to 1. Then we also count the pick, how many you pick and how many you put. Then you put the subroutine of pick and the subroutine of placement in the loop. Then we also count the number of variable. Make it in this program, we have 6 piece need to pick and put in the palette. So you did when it's 7, you just skip out. Okay, so because this is for our training in the platform. In the after the training, you can track this presentation. Maybe you can try to create something similar. So the second part is about Modbus communication. So it's an for our robot, our controller, we can use Modbus TCP, and for our tool IO, we have Modbus RTU. We can use RS485 IO to control the grippers or some other tools. But for our controller of CR series, we only have you can only use Modbus TCP. The history of Modbus I'm not going to introduce, and actually there is a application layer. So Modbus works on the layer 5 in the TCP/IP Ethernet reference model. It's in the application model. It's not about the connection. It's just a protocol message. So for the structures, there are 4 types of core of registers in total. The first one is core register, and the which can be read and write. Normally it's the output of PLC. If you connect it to a PLC, So it's the output of PLC. It can be changed, and you can read, and also you can write some of the address. The second one is the discrete input registers. This one is read only, so you can only read its number from the discrete input. For the input registers is also read only. So it's normally is the analog input of the PLC. So it's only read only. For the holding registers is also readable and writable. So based on these 4 types of registers, we have 8 functions code, 8 function codes. 01 is hex. This one is in hex. 01 you can read coil register, write, and 05 write single registers. These functions you can try it with the Modbus, some Modbus tools, and communicate with our robot. I will also show some simple demo later. We have the definition for all the Modbus address, and of course you can also have your own definition. Some of the addresses they are reserved. So if you need it, I can share the document for the Modbus definition. So in our robot we have 4 types from address 1 to 9999 is get set coils. So it's coil registers from 10001 to 19999 is in bits. And the other definition also here. So for our CR controllers, so each of the function we have 4096 address can be used. Like so Modbus TCP also used in PLC communication, like for the temperature sensors. Then it can interact between the robot and the PLC. To communicate with via Modbus TCP. So here's an example. There's 3 steps. First one is to create the communication and do a simple test. The second one is transfer data via Modbus. The third one is robot's movement. It's like the robot get the command and do some motion accordingly. And also we can use the address to record the number. So the first example is we establish Modbus communication between the debugging software and the robot. We can also use the debugging tool here. Okay, when you open here, oh, I forgot to show you this. Here you go to help, then you can get the debugging tool. So with the debugging tool, you can use these functions. Okay, for example, Modbus tool, you can connect here. Okay, Modbus RTO, Modbus TCP. Of course, for the monitoring, you can also use here Modbus here to check the Modbus status. So when you start a robot as Modbus TCP server, it will create. We can use the command to create Modbus input Modbus slave ID and some other parameters. So debugging tool also connect to the robot server. So the debugging tool is the client. Then the robot writes the value of the sum of the coils. Then the debugging tool read debugging tool read the values. And when the debugging tool change the values, the robot also read and print the data. So let's go to here. The first command is create Modbus master. Then you input the IP. The IP address is Modbus slave address. Okay. And the port, we use the default port 502 for Modbus TCP. And the ID of Modbus slave, the range is 1 4. So we support 4 slaves. So you can work as a Modbus master and the PLC as a slave. Then you input the PLC address, port number, okay, of PLC, and the slave ID of PLC. The other one is Dobot work as a Modbus slave and a PLC as a Modbus master, and input the address of the Dobot. So the IP always is the slave IP. Okay, the port of the robot and the slave ID of the robot. Normally we start from defaultly it will be starting from 1. And these are the functions to read coil registers, write coil registers, wait coil registers. So the details, I'm not going to read them. So when you are using it, you can read this document, the training document, or also you can read the manual of our Modbus address definition. Okay, the other get coil registers array address. And you can get an array. Maybe you put address 0 bits, you put 8, so it will get 8 bits. And also you can write multiple coils registers. The starting address, the address means the starting address, and the data, you can put all the data here. Here's an practice, and I've write some demo. I've write a simple demo. So the first step, you create a slave and connected it with Modbus port. You can download this tool, Modbus port, or also you can use our debugging tool. Then the robot write coil instruction. Then the robot write the value of address from 1000 to 1004, make it 1. Okay. Then the robot write 1 to 1006, but 1 to 6, 7, and 8. Then print the value from 5, 6, 7, 8, and 9 of the Modbus address. The coils, okay, the coils, and the weight the coils of 1010 to be 1. And when it receives this 1, it write this 0 to this coils. Okay. In this practice is using Modbus port a debugging tool, but I can use this one. To saving time, I already written something. Okay. So here. So first create Modbus master IP. You can find here Modbus create Modbus master. Then IP, you input the IP address of the slave. The port, we use the default 502. When you connect to our robot, you need to use the 502. And then you print the create result. Okay, so get the print here from here, and the result of Modbus, get create Modbus master result. Okay, then you set 1000 and 1, 2, 3. These 4 address, set them to 1. Okay, so you input 1 here, input 1. and 1 here. And then you also set 6 to 1. And you also set 7 to 1 and then 9 to 1. Okay. Then you print it out, you get coil registers array. You got 5 bits. Okay. Starting from 1, 0, and 5, get 5 bits and print it out. Use the same sync print. And you wait until 1, 0, 1, 0 become 1. Then you set this 1, 0, and 2, 0. Okay. Set this 4 bits to 4 coils to 0. Okay. So you can use this one to connect Dobot IP. Dobot is slave IP port. Slave ID starting from 1. Okay, you choose function 1, coil status. So address starting from 1000. Okay, so we use 20 address. Scan rate, okay, you can use the default one. Yeah, okay. So once you start to run the program, let me switch off the proxy. Because 10 here is already 1, so that's why, and take it off first. Let's run it again. Okay, so the first step, it will write is 1 to here, right? And also write 679 to 1, right? And also print out 0 and 5 starting from 0, 5. So it's 0, 1, 1, 0, 1. Okay, 0, 1, 1, 0, 1. Okay, so it will wait until here is 1. So I make it 1. Okay, I make it on. Okay, here will be changed to 0. Okay, it just show a simple function of the registers, how it works. Okay. The second demo is we use the same. We use the robot to communicate with the debugging software. Like this, when we start robot as a TCP server, then the debugging software also connect to the robot. And the robot read the data of holding register 1000. This time we are using the hold registers. Okay, 1000. Then then send the data to hold registers. Sorry, here the debugging tool send the data, then the robot read the data. Okay. So it will check if the value is 10. If the value is 10, it moves to P1. If it's 20, move to P2, and so on. Then then the debugging tool will read the data of register 105. After the motion, it will write the data of register 105. Then here will read the data of 005. Okay. Here's the function of set holding register address. Okay, you input the address here, data, and also input the data type. Okay. Here are the defines of all the types. For example, U6, 16-bit unsigned in integer. Okay, 2 bytes, 1 register. So means 1 register is 2 bytes. 4 bytes, 2 registers. Okay, and so on. You can also get the registers, get the data, and also you have the same to wait the wait until the holding register address. So here is the simple demo. So you first create a connection with Modbus core, and if the value is 10, so you move to P1, then you write value of address 200. If it's 20, go to P2 and write the address of 0.5 to 200 and so on. Okay, here is the demo, and I should show. Okay, so first we create the Modbus and input the slave ID, Robot IP, slave IP, and the port and the ID. Okay, then then we check, we get the holding register address 1000 type U16. If it equals 10, okay, if it equals 10, you move to P1 and set holding register address 05 to 100, and also you print reach P1. Okay, you print reach P1, and the other also the same. Okay, so the same P2, P3, P4. Here I already taught the points, so I can run it directly. So here you can also go to Modbus. You need to break it and connect to holding registers. Okay, the IP address, port, holding registers, quantity, we also choose 20, it's fine. Current value is 40. Let me make it other value, make it 50. Okay, so let's run this program to see. So show the robot here. Okay, so let's input 10 here. Okay, we send a 10. So the robot move to P1 and print reach P1. We input 20. Okay, to P2 and reach P2. Okay. It goes to P4 and print P4. Yeah, that's a simple function of the holding registers. Okay, you can also define the registers as the other functions you want. Okay, the next one about the input registers. We also have the similar functions. Here are the explanations of these blocks. You can also get an array. Get an array and how many bits. Okay, this is another a detailed another practice is combined with the training platform is combined with the project which is created via IO. Now we use the Modbus to do the same program. So because it's online, so I cannot show this. I cannot show this demo, but the theories they are similar. You remember the pilot issue, pilot program. We just change the IO to the Modbus registers. Okay, they have the similar function.
Can I ask a question?
Yes, no problem.
So you're basically talking about the Modbus TCP communication between
yes,
master and slave. So is it possible to have connection with multiple slaves, which I think it means that multiple slaves mean multiple robot arms, right? So can we have like a client application which is connecting to multiple robots using Modbus TCP?
Multiple. So you mean you have your PLC and connect to our robot, different robots, right?
Yeah, so getting data and controlling two different robot arms.
Yes, yes. So our robot is slave. It can be done. Yeah.
Okay, so just like you're creating connection between one master and one slave, we could have multiple slaves, right?
But in this case, our robot is a slave. So there's only one slave. Like compared to your PLC.
Okay, but do we need PLC in this case, or just we could have just two robot arms or three robot arms?
You want to use the same debugging tool to control?
Yeah, same debugging tool to control like two slaves, for example.
Find the debugging tool. You want to use something like this Modbus Pro debugging tool. Then you connect two robots.
Yeah, to control like two robots. So for example, those two robots could be doing something together, okay, collaboratively. So in that case, we need to control both of them, right?
Yes. If you can connect our robot, you can do that. But now the problem is this tools cannot connect two robots. Our robot supports 4 slaves. It's like one robot can connect 4 slaves. One master can connect 4 slaves.
And what what is the master in this case? Your software application you're using is the master, right?
Yes, so this one is the master, and
Okay.
the robot is the slave. So,
Okay, so in that case, you can
yeah.
connect 4 robots, right, to this application.
If the yes, we can connect 4 slaves. Yeah.
Okay, through this. So there is an option to specify an action by a certain slave, right?
Yes. Only
Okay.
1, 2, 3, 4. We can connect 4 slaves. Yeah.
Okay, great. Thank you very much. It's clear.
Okay, so let's go ahead with the remote control. So I just mentioned here in our control software, you can use the Modbus to control different programs. Okay, so here you choose remote Modbus, and you choose one of your project. Maybe some new project. Okay, then you write the codes to start and stop, and also it will show the status in different address. Okay, so these functions are the similar, so I'm not going to show it here. But for the virtual controller, the communication cannot be used. The virtual controller, because there's no real robot, so it cannot be a slave or master. Yeah. So for the virtual controller, you cannot use these functions. Okay, the next I need to specify is that for the introduction of the Modbus or the TCP, I just introduced some basic usage knowledge or the demos. And if you want to use more functions, maybe you need to go detail to our user manual and also the Modbus definition. Then you will find some more functions. Yeah. The next part is about the TCP/IP protocol. I think maybe most of you have learned the protocol of TCP/IP communication series, like 3 times here, three times or 3 ways handshake, and 4 times for wave hand. Okay, So it's about the TCP communication protocol on the theory. Okay, I'm not going to introduce this. It's like just like if you want to build the communication, you at least these 3 steps. Okay, to close, 4 steps. So in TCP IP applications, normally we will transfer the coordinate, like we integrate the camera with our robot. This one camera is on the top. Is eye outside. The camera is outside robot. So we use the TCP IP to transfer the camera coordinate to the robot. Camera here, take a picture and send the coordinate to the robot, and the robot will take the path to the destination. Yeah. Okay, this is about the beam picking. So normally we use the TCP IP protocols. Of course, it can also be used in other applications. Okay. So there are also some basic steps like create TCP server, then transmission, transfer the data, and the data pack processing, like to process the data you have received, and calculate the point. If the camera sends some coordinate to you, you need to do the data calculation. Here's an example, like when you start. So our robot create TCP server, and the robot is the server, and wait for the debugging tool to connect. The debugging tool will open a client and connect to the robot. So the robot, when it's connected, the robot will send a string OK to the debugging tool. So the debugging tool, when it receives the OK from robot, it will send hello to the robot, and the robot wait the debugging tool to receive data. Okay, then wait to receive the data, then also print out the received data. This is just a simple communication between this robot. So for the TCP IP in Broccoli, we have connect socket. Like connect, you choose the socket and the IP address and put the port. So this one is create TCP client, okay, and communicate with the TCP server IP address, server IP address here. IP address of the TCP server and also the port. This one is create TCP server and wait for the client to make a connection. So the socket number can be 4 in total. The IP address also the same TCP server, and the port. Need to note that these two, 502 and 8080, these 2 ports are occupied, so you cannot use these 2 ports. The other ports you can use. Okay, and the close socket, and the send variable to a specific socket, and the get variable. So when you use this one, you need to define a variable. So the timeout, wait timeout, if you set to 0, it will not time out. It will keep waiting until it receives the data. Here's also a practice. You create a TCP server and port. When it's connected, you send OK to the tool. Then the tool will send a text to the robot and also print it out. So we create a socket, input the IP of the robot, because when you use the create, the robot is server. Robot is a server. The tool is a client. So you input the robot IP. So if you if the result equals 0, it means you created successfully, right, and connected successfully. Then you send the data, okay, to the client. Then you also then the client will send you something. Then you use the get variable and you defined a string variable named TCP read to read this data and also print it out. Okay, for example, here, let me also try it here. So you can use the debugging tool. Okay, we create a socket, put the IP address of the robot. So means the robot is a server and the port 6801, a default one. And if the result is 0, means create successfully. Then we send reliable, okay. Then we also get the reliable. So here you need to define a reliable, make a reliable string, put the name here, okay. Here I already created, named TCP read, okay. So when you create it, you can get from here, string variable, same one here. Then you also bring it out. Then you open the debugging tool, sorry, debugging tool and net tool, TCP. In this case, is TCP server is TCP client. So input the server address and 6601. Okay. On this tool, it will cut the connect. So we have to run it first. Then we connect. So it send OK to here. Okay. Then we send a test. So here it will print out the test. So it will close by itself. If you are using some other tools, you can also do the same test. This means we have built the communication between them. Okay, here's an example. Like we use the TCP, we use the debugging tool to send some coordinate to the robot. So first we create TCP server, also create a TCP server, and the debugging tool should be a client. Then the robot is waiting for the data, so the debugging tool send this to the robot. 120 to 200, 300, and use the comma to separate, but it's in string. It's in string format. So the robot will get this data and will split this data with the comma. So it will get 100, 200, 300, and the robot will get the second one. So it should be 200 in this case, and send to the debugging tool. Okay. So in this case, we need to use these blocks, these functions of the string functions, which is here. We need to use the string functions, which is here. So the first one, convert string to array. So when you receive the string, you need to convert it to array, okay, and put the separator. For example, you if the string is 1, 2, 3, then use some separators like this. The separator is this one. Then we convert array. Will after conversion, it will become like this, an array, and the first is 1, the second is 2, third is 3. So it will return the converted array like this. Okay. And get the element with specific superscript. For example, if you want the second one, third one, so you need to input the array here and get the access number here. For example, the subscript of 8, 7, 8, 9, 8 is number 2, so you input 2 here. So it will return the specific location in array. So we also have a practice here. So you create variable TCP read to store this variable, and you use split data to store variables from splitting strings. So you use split data to split the strings. And we use debugging tool to send a set of data, for example, 100, 200, 300, and with commas. Then the Dobot will receive it and print it. And the Dobot robot can send second one to the debugging tool. For example, here. Okay, I can also show here. So we create the server and get a variable. So here you need to make a variable in the custom, make a variable, string variable, name TCP read. Okay, you can put any name, TCP read. Then we put wait time 0. Then also print the data you have read. And then we set, and then we need also to convert when we get this string variable, we need to convert it to an array. So you can use this convert string to array. You can use this one. Then here you input the data you read here and put the separator here. Okay, like this here. Then after that you set. Okay, set the split. You also build a number array. You also build a number array. Make an array. You put make an array. You and set it to this figure. Okay. When it's done, you print out the number array and also send the second one to the debugging tool. Okay, so you need to get the second one. Okay, use this one. Like the number variable split. Okay, you build a variable name it split. Then you get the second one. You can put the second one or third one here. Then you send it. And you send it to the debugging tool. Let's have a try here. We run it, and we also connect it. So we input 100, 400, 300, and we send. Okay. The robot get these 3 numbers and transferred it to an array, 100, 400, 300, and the robot get the second one and send back. Okay, send back to the debugging tool. Here's another example, like create a TCP server, and when it's created, we send OK to tell the debugging tool we have created, and we have moved to the initial point. Then the debugging tool will send the coordinate, okay, offset data. So we use the relative movement command. The robot, the debugging tool will send the offset data to our robot, and when we get it, we will process it, and move to the right position. So when it starts, we create TCP server, and at the same time, the debugging tool will open a client to connect to the robot. Then after the connection, the robot the robot send OK to the tool, and tool when it receive it, the tool will debugging tool will send go, okay, go, comma x and y, x comma y to the robot. Then the robot wait until it receive the data. Then the robot needs to process the data. It will split the data. Firstly, it will convert the data to an array. Then use the comma to split it. So if compare the data with the string with end. If the robot receive the data is end, so it will end the program. If the robot receive the data and compare to go, when it receive go, it will check the other figure, the other value of x and y, okay, and it will move to the it will move to a relative moment to the target position and send go okay to the debugging tool. If the first part is not go, okay, it will send go ng to the debugging tool, and debugging tool receive the data from the robot. Okay, let's try. Let's see this to realize these functions. What tools we need, commands we need. So here we need to splicing two strings. We need to use the string splicing, or we can also use the string to array, then use the comma to do the splicing. You can also, and you can also compare two strings. Okay, for example, you compare the size of two strings according to ASCII code, like to compare. For example, you compared ng with end. Okay, so the result is not the same. Return 0 means this one and this one, they are the same. So return minus means this one is less than this one. Okay, you compare 1 and 2, so it will return -1. You compare 2 and 1, it will return 1. Okay, the first one is greater than the second one. That the specific you can also set, or you can also change the element of an array. Okay, you put the array name and index and the value. So and the also the practice, we create a server and the IP port. Port here you can put any port you want except the other 250 and 8080. The robot move to P1 after connection, so it moved to the home position and send OK to debugging tool. And the debugging tool will send value in this format, go XY, and robot receive the data, and also will split the data, use the comma. So if the received command is go, robot will do a relative movement based on P1. When it reach, it will also send go OK to debugging tool. Otherwise, it will send go ng not good to the debugging tool. When the robot receive end, so it will finish the program. Okay, this is the program. I can also show here. Okay, we do the same, include TCP server, and we move So we get the data from PCB current, and we also print it out, and we as here name it as split. Make a variable. You can put it split. Then we convert it we then we do the comparison. If so, we compare the spring rate and end. Okay, if the result this one, if this one compared with end, if the result equals 0, so it means it received end. So it will print end. So the program finish. Else if if we compare it, we get the access point number 1. If it's go equals 0, so it means the first one is go. Okay, so we do a relative movement. Okay, move to current point. Here, current point is here. It's P1 because it already reached P1. Current point. We do an motion from the X direction. We go to we get the second access. Okay, for Y direction we get the third access. For Z we just put it 0. If there's some value you can also put here. And when it moved, it reached, we also print go. Okay. If it is not if it's not go, okay, we can print go NG. Okay, just a simple program like this. And we also do the same to test. Okay, we start the program. Then we connect here. Okay. We send end to check. We send end. Okay, the program finished. It received end and also printed out end. Let's connect again. Then we put go 20 millimeter and 20 millimeter. Okay. Okay. It received go 2020 and also it was transferred to an array. The first one is go, second one is 20, third one is 20. Okay. And it will do a motion. When it move to the right position, it will send print out go okay. It print out go okay. Okay. Of course, you can also send some figure to here to say go okay. Okay. So if maybe you input something long, you input like GM. We try. Oh, not yet connected. Okay, it will say go ng, so means the commands are not correct here. Okay, here just show some simple basic functions of the TCP/IP and the Modbus. Any questions about this part? Maybe we can go ahead to finish all the training because the other parts are not a lot. We can finish the other parts, then we can have a Q&A. We can have a Q&A session at the end. Okay. Number 5 is about the Lua script programming. You know, we support Broccoli and we also support script. So for the script, we are using Lua language. Okay. So if you never learn Lua, maybe you can have to learn Lua first, and because Lua is easy to learn and very user friendly to read. So for the control panel, is easier as I introduced. Also, the commands are all here. You can program here, and here you can have the global Lua to put some logic or the global values here, and you can also add other sub threads. You can also add sub threads. Sorry, subroutines here. You can add I think at most 5 or 4. Yeah, at most 4. 1, 1, 2, 3, 4. Including the global, you can use 5. Okay, subroutines. And for the basic syntax, these are easy to understand. Just the Lua basic grammar. Okay. I'm not going to read this contents. Okay. And also for the control command for the logic. So the global variables you can define in the global Lua. Here you can define the global variables here. And also you can define the global functions, okay, the points and so on. Okay, for example, function, you can define a function with the function, then some keywords and an end. For example, the function of this exam or test is print this an example. So in global function, you can define this one, and in the main program, you can call this function, okay. And the global points, you can also define global points. For example, P, or you can put PN here. Arm orientation joins for user 0. You can define the value here. Okay. Global variables, you can put the flag. The default value is 0. So this you can define here. So in the main program here, it will be clearer, easier to read. Okay. In our robot controller, we have 2 commands. You need to understand there are 2 commands. The first one is Q commands, and the second one is common command, is the execute command. Okay, the first one is Q command. It means the the program will be carried out line by line, one by one. Okay. The execute command means it will once the program start running, this command will be carried out. For example, here, here's an sync command. Okay, so here, for example, you move to P1 and set the DO1 on, and here. So here is an queue. So normally all the commands will go one by one, right? So firstly, you will move to P1. Then second, DO will be, when it reach P1, DO1 will be on, and wait 100 milliseconds and move to P2, and check the grab status. Okay, check the grab status whether you have get the target, get the workpiece. So if you did not use sync command, okay, so it will check the DI1. It will check the DI1 because the robot is when it's moving to P1, the execute DO is an execute command, so it will also be carried out during its moving to P1. Okay, so it will reach here very, very fast and will detect that DI is on. It means it's grabbed, but actually the robot is still moving, still doing the motion. Okay, so in this case, we need to use sync. For example, here, go P1 and sync. So it will reach P1 and then it will go to next step. Okay. For example, you can also put the sync here. You can put the sync here. So it will complete all the commands here. Okay, then check DI is 1 or not. Okay, and there are some standards of the we can say that's the a common habit of the programming standard. For example, for the functions, we also we normally use the capital as the initial capital initial for functions. For example, connect function, receive data function, Dobot initial function. Okay. And for the for the other, like the first initial should be in lowercase for variables. Now for variables, when we define it, normally we will use lower letter, and the second one we use the big one. Okay. These are these words. Not going to read them. It's for some specific definition. So for the standard, we know, of course, first one we need to in accordance with the specifications like of the Lua. Then the robot return to the home point and wait for the button to be pressed. This is an a small demo for this programming. Then return to home position and pick up, complete, and back to home printing. The programming standard. So normally in the beginning we will write the purpose, like the of all the function of this program. Okay, and also some tips. Okay, some description of the process. So if there's some other guys wants to read your program, he just need to read this first, then he knows what is this program about. Then you define the functions. For example, you have an initialize function. You set the speed here. Okay, also set all the IOs to off, and also go to the home position. And then the second function is pick something, right? You go to the point. The third function, you define a put function here. Okay, put function here. And you also have the description here. Then in the main program is very simple here. You just first you just need to call the initialize function. So it will do all the functions here, and you put loop here. Not right sync as Y and C. And you check the IO. If the DI2 is on, then you do the pick function. Okay. If DI3 is on, you do the put function, then sleep. Then the IO will be in a subroutine, which is checking the IO. So the program will become very simple. Of course, it's better you also put some marks here for the easier reading. Okay, it's talking about the same thing. Okay, for example, here, we put more explanations here, like total count number. You put some remarks here. Okay, so it's easier to understand. Okay, or talking about the same program. And sometimes you can use some functions. For example, a function of palette. You can define a function and for a lot of scenarios. Okay, here's a bit complex calculation, but in some case, if you write a function which is good, then you can share the functions to use it. Okay, here's about the palette calculation function. Okay, and after the programming of script, normally we need to do some debugging before we run the program, right? So you can use the print to do the debug. If you run a program and then there are some errors, you can use the print to print out in some specific point, to print out and check where is wrong. And the second one, you can use the sync command to synchronize the motion of the robot to make sure that the robot is moving correctly. And also you can use the debugging, our debugging tool, step debugging or break to do debug. For example, in this, you can click the number here, so the debugging will reach here and stop. That's all for the training of advanced training. Okay, for the programming, okay, you can do some practice by yourself if you want. Okay, and in with the virtual controller, you can also do the practice. Okay, then we can also have some time for the question and answer. If you have any questions about this, about our robot, about the training, and about anything related, we can communicate in the coming time. Okay, thank you.
Thank you very much, Simon. It's we are overwhelmed with with the material. We need time to digest.
Because it's online, so the problem is we cannot try it one step by step. Yeah, but since you already got our robot and you have these materials, and I can also share some more materials, like the user manual, the model bus definition, TCP/IP definition APIs. So you can do the practice, and any questions you can ask me. Yeah.
Okay, I think what I think what is important is afterward. You know, this is like today's like introduction for all of us, especially the students. Later, when they will do practice on their own, both virtual as well as they come to the lab on the robots, the question will arise. And
yes.
how? Yeah, if we face problem or we have question, do you have such like online help or maybe email? We can contact you. Like
yeah, no problem. I will share my mail address to the chat box. Yeah.
Yeah, I know definitely once we work, when we are familiar, we will have a lot of questions. But now,
yes, understand. yes. Yeah. So my opinion is that you need to spend more time to do the practice. Then during the practice, you will find a lot of problems, or a lot of questions. Then we I can answer them one by one. Yeah, that will be better. Yeah.
okay. Our students those who still remain, most of them already left, but those who are still staying, you have question you want to ask, you're welcome. It's for you.
Okay, so I've shared my our technical support mail address in the chat box and also my mailbox. Okay. So like any questions you can send to this mailbox, so we will reply. Maybe sometimes not me, but we will reply. Yeah, maybe my colleagues for this area for this region, we will reply all mails. And in the WhatsApp, the family messaging, sometimes we are not online, so maybe sometimes we cannot reply you in very fast manner. Yeah, but for the mailbox, we will reply. Yeah.
Okay. Another things, actually, we have been discussing about the Dobot itself. One thing we have not done, we need to connect the any factor. We have the with the Dobot, we put the one any factor, and we're planning to buy 3 other combination from DH Robotics. Yeah. So we have this but we will buy more this year. So the idea is we need your guidance how we can connect. And I mean, you mentioned about the weight, right? The weight that should be properly configured.
Yes, yes. This one is AG95.
I cannot see it.
Is there any flange to connect the grippers to the robot? Normally,
we have the one gripper, and we're planning to buy three or four other combination gripper.
You buy from us or you buy from DH?
It is DH brand.
I can I think I can share a list at which grippers are compatible with our robots. Yeah, so it's better. Yeah.
Simon, it is the AG105.
AG105.
Yeah, you can see, right?
Okay. Not clearly, but should be no problem. Yeah, should be no problem. I can share the like the manuals how to install it. Yeah, it's not difficult. It's not difficult. Yeah, but I don't think you can. It's a good solution if you put it on CR3. This one is a bit heavy if you want to take something. But if you just for the demo, it's no problem. Yeah.
Yeah, it is for further demonstration. We will not put the heavy load. Maybe like we'll pick up an empty cup or something.
Then that's no problem. Yeah, I can share the manuals like how to install it on our robot.
Yeah. We are thinking of like we will buy similar like the one you shown on the demonstration, like the suction, also maybe some soldering or maybe some microsurgery and infected.
So sorry, I didn't get you.
We have in mind we'll buy like suction manufacturer, also this welding or soldering, and maybe also another one for the microsurgery.
Okay. But for the welding, need to confirm. Is it compatible with our robot? Yeah.
Not simple, not because we have our small lab. Maybe we just use like soldering, like electronic soldering. Just simple demonstration that. Yeah.
Okay.
Very
If
very lightweight.
Okay. Yeah, and that's no problem. So like if you want to like integrate with some other end effectors, you can consult with us first. Yeah, then we check is it compatible or not. Yeah.
Yeah. I know the one from TH, it is compatible because actually we got the catalog from them. So
Oh, okay, okay. By the way, how many robots you have now in?
now we have 3. At least for now, I think 3 is enough because we do have space. We have a small room.
Okay.
Yeah, but we are planning this year. We'll buy 3 more any factors.
Okay, okay. Is they are all 3? They are all CR3?
Yeah, CR3. CR3,
Okay, okay.
and the meanings for each combination and the any factor will buy 3 each.
Okay, understand. Okay.
We are thinking also this year. I'm just last week we are thinking for the new budget. We are thinking a smaller robotic arm. What's it?
Magician.
Yeah, magician. Yeah.
How
It
about
is-
E6? Do you want magician E6? Is also six axis. Yeah.
The idea is we want to like this one. It is heavy. It stay in the lab, but the small one we are thinking that student will work it on their own. Like we will assign them. Yeah, like for their control project.
Okay. You can consult with